Hello everyone. Welcome to Applications Manager free training series on applications performance monitoring. So let's jump into today's agenda. We are going to cover overall four parts. In the first part, we will discuss and understand the application performance with APDEX course. In the second part, we will explore on how you can monitor code flows across your applications via distributed tracing. In the third part, we will be looking at how you can directly pinpoint the problematic elements in your application code. Lastly, we will visualize the dependencies in your application architecture with the help of automated service map feature available. So now here are some of the recent facts that we have gathered from the trusted sources like International Data Corporation and Forrester. So according to the International Data Corporation, 90% of the respondents are currently using observability tools, and this gives the administration a deeper insight to drill down into the information of their application. So further, Forrester's research report states that 87% of engineers said that using a cloud native architecture has increased the complexity of discovering and troubleshooting the incidents. Before discussing the topics in the agenda, let's start with why application monitoring is required and essential for today. So just imagine a user who is accessing an e-commerce website and trying to purchase a product from the online store. So after searching the product, adding the product to the cart, and they are trying to attempt to place the order. So now at the time of placing the order on the payment portal page, they encounter issues like the portal taking long time to load or getting redirected to a different page or some other errors like the 404 error or the page is getting down. So this operation could lead to the loss of potential customers from accessing your application and lead to a loss of business as well. And for the developers who are working on this web application, they will be unsure about the root cause of this issue. So in this scenario, the demand for using an application has increased, which also led to the complexity of its development. So hence, it is necessary for developers who are working on the application to make sure that website is bug-free and can handle the load in the application database to ensure providing a better service to the users for a hassle-free experience. Now, adding to that, we here are some of the contemporary trends in the application monitoring. So let us see one by one. The first one is cloud native applications. Nowadays, simply larger enterprises have adopted to move of many of their applications to the cloud, where cloud native applications are scalable, flexible, and also efficient and use small independent building blocks like the microservices, containerization, commonly Docker and Kubernetes also used. So developers and the operation team work closely together using DevOps practices for faster and more reliable software delivery, such as the monitoring these applications is essential nowadays, and which is also helps in analyzing how each part of the application is working and trying to fix any issues in handling by handling a lot of users. So that is how the cloud native applications. And the second one is the artificial intelligence for IT operations in the context of application performance monitoring. So AI and machine learning in the recent times have been used to enhance and automate IT operations through anomaly detection for identifying unusual deviations and to automate IT tasks and predictive analysis for potential future using the historical data. So which is also can be optimize the resource allocation for scaling based on the real-time performance data. So that's how the artificial intelligence for operating operations capabilities. And the third one is a user-centric monitoring. So with help of this user-centric monitoring, which shifts the focus from system-centric metrics to the actual end user's experience. So especially when interacting to an application, users experience is measured you by examining the journey from the moment they access the application to completion by identifying the user-centric metrics. And the user-centric metrics that we use are such as the page load times, response time, and the overall responsiveness of the application. So by helping developer to prioritize improvements and enhance the user satisfaction as well. The fourth one is application observability. So application observability, including application performance monitoring, so will help in gaining insights into your application performance behavior, and also the health of an application, which is achieved through monitoring applications, transactions, trace logs, execution times, and identifying the bottlenecks, errors, and inefficiencies in the code. So which these metrics can be achieved with the help of the application observability. And the last is the full stack performance monitoring. So the goal of full stack performance monitoring is to identify and address the performance issues across the entire application stack, starting from the end user interface to the backend server infrastructure. So by monitoring the various layers of the stack, including the application code, server response times, and the database queries, this is achieved by collecting the real-time data on various performance metrics like the response time and the error rates. So as we discussed on this five major contemporary thing, and by adopting these latest trends, organizations can gain more insights into the performance of their application in real time by enabling them to proactively identify and also resolve any potential issues before they impact the end users. So this will ensure that for maintaining reliability, availability, and responsiveness of the modern applications as well. Now here, let's explore the benefits of modern versus traditional approaches in building an application. So first, in the traditional approach, the applications were hosted on the on-premise or a single data center server, which can be experiencing high downtime and limited availability. So which also leading to potential performance issues during the traffic periods. However, leveraging cloud computing and containerization for better availability and utilizing features like load balancing, redundancy, automatic failure, and global distribution has minimized the downtime, enabling continuous deployment without affecting the user experience. The scaling of traditional applications involved purchasing additional hardware and substantial investment in the infrastructure. And then high maintenance costs are due to the need for physical hardware updates and repairs. So with a cloud-based solution, reducing the upfront cost, allowing efficient resource utilization, horizontal scaling of resources based on the demand, automation, and containerization contributed to the operational cost savings. So the third one is the global content delivery. Content delivery may be constrained to a specific location or a data center. So where the users in the different regions might experience latency and slower performance. So using content delivery networks and edge computing will ensure a faster and more reliable delivery globally. And last, and then cloud services offer a distributed content across multiple servers globally. So reducing the latencies for user worldwide, this improves the user experience and ensure consistent performance in worldwide. So the last is operational efficiency and managing which is help to managing and maintaining the traditional applications will involve manual processes of the deployment, scaling, and maintenance with limited flexibility and agility in responding to the changing business requirements. Now, DevOps practices such as infrastructure as code, continuous integration, continuous deployment pipelines, and container orchestration tools will automate the process, enhance operational efficiency. The microservices architecture enhances agility and scalability for evolving applications. And then updates can be rolled out seamlessly without any downtime, and resources can be managed programmatically. So, in summary, adopting a modern approach to building applications will offer advantages such as improved availability, cost reduction, global content delivery, and operational efficiency. So, when compared to the traditional methods, cloud computing, automation, and modern architectural principles are key factors that will contribute these benefits. So, and also it enables businesses to stay competitive and responsive to the changing demands. The modern approach will offer benefits such as improved scalability, reliability, and global content delivery, and which can be also contribute to the higher availability when compared to the traditional approaches. So far, we discussed why application performance monitoring is necessary using Applications Manager and as per the latest, technology trends. And here we have the performance monitoring feature in App Manager, which is also called the APM Insight. So APM Insight will give you an understanding of the way how your application behaving for your end user who are accessing it in a complete by end-to-end transaction monitoring. So starting from the front end to the back end, what are the transactions that your application is performing for the end users, whatever the transactions that are happening, and what is the performance of your application. You can completely track the performance, so which can also help you to analyze the root cause of the problems much faster by performing the first level analysis and the first level troubleshooting. And when it's come to the APM Insight technologies, the supported platforms are Java, Node.js, .NET Core, Microsoft, PHP, Ruby Rails, and Python. So these platforms, if your application is hosted in any of this platform, using any of this platform, so we can monitor it under the APM Insight feature. So here, these are some of the factors that will play a crucial role in determining the performance of an application. So let's see each one of these factors. The first one is the response time. When a transaction is made by a user in the web application, the request is sent from the application layer, which will travel through the transaction and the network layers, and then it will hit the application server, and this request served back to the end user. The response time is taken for a transaction to be processed, which includes the time taken from initiating the request to receiving the final response. The query response time is taken by the database query to retrieve and return the database data, or the speed at which the database queries are executed. And slow queries can significantly impact the overall application performance as well. The application performance response time is the time taken by the application to respond to the user inputs or requests, so which will include the processing time, the network latency, and any other delays. So the application code, we know that bugs in the application code can lead to the unexpected behavior, crashes or performance degradation, inefficient or excessive exceptions. Handling can impact the overall performance, and the frequent exceptions might indicate issues that need some more attention. So when error occurs, a stat trace provides information about the sequence of the function calls, which can be leading up to the errors. So analyzing stat traces will help in identifying the sources of the performance issues. The third one is memory. So monitoring the application's memory consumption is crucial. So high memory usage can be lead to performance issues and even crashes. So if the application exhausts its allocated memory, it might crash or become unresponsive. So this occurs when the program doesn't release the memory properly, leading to a gradual increase in memory usage over time. The last one is the database. So database queries that will take a long time to get executed can impact the entire application's responsiveness. So optimizing these queries is very essential, and the number of calls made to the database can impact their performance as well. So reducing any unnecessary or duplicative database calls can improve the overall speed of the application. Hence, the monitoring and optimizing these factors are essential for maintaining good application performance. So various monitoring solutions can help you to identify and also address performance issues in each of these areas. Also, regular performance testing and tuning are very essential for ensuring the application to run smoothly. So further, website performance can be impacted several using the several key factors. So this includes schedule maintenance and data center or the server errors, so which are often unavoidable but should be well communicated. No, so and bugs in the code can lead to instability, while high traffic spikes can overwhelm resources. So hacking attempts pose security and availability risk, and failure to renew SSL certificates can result in trust issues and access disruptions. So proactive monitoring and timely updates are essential to minimize downtime and ensure a smooth user experience. So as we talked about the features, this is one of the thing where the application performance monitoring insight is a tool that uses the agents for the monitoring the application. So this is agent based monitoring, and the initial step will involve deploying an agent onto the servers where the applications are running. So these agents are responsible for gathering the performance data and transmitting it to the applications manager for analysis. The agent within the application server utilizes a method bytecode instrumentation technology so to track the individual user transaction as they navigate through the application stack. Then it will send this transaction data to the applications manager at a fixed time interval. So the approach will enable detailed monitoring of the transaction performance, facilitating an identification of bottlenecks or any performance issues. So the tool will offer code level visibility, allowing monitoring of slow database queries and their performance by capturing the real time user interactions happening on your application. So users can configure any alerts and notifications based on the predefined threshold that for the metrics that impact their application performance. So when the application performance reaches this threshold, the tool will send an alert to the IT team. So this alert system will be helpful for the developers and IT team to pinpoint the areas that require improvement in performance, such as the application code, database related issues, and page load times. So this proactive approach helps address the issues promptly and to minimize the downtime. So let's see exporting and elevating the performance using the APM Insight Data Exporter. The data exporter is a standalone component or a module within the applications manager for collecting, processing, and sending application metrics and traces for communication with the application manager server. So its purpose is to export the data related to the application performance monitoring insight. So the data exporter operates as a separate independent process, which means it will run automatically from other component or services within the applications manager. So the primary function of the data exporter is to handle and transmit the information related to the application metrics and the traces to the applications manager. So the metrics will include various performance indicators such as the response time, the error rate, or the resource usage, and the traces as well. So typically, which will refer to the detailed records of the execution flow of the transaction or the request within the application. A single instance of applications manager data exporter is capable of managing and data processing for multiple applications. So this implies that the exporter is designed to handle the data exporter requirements for various applications simultaneously. That the exported data is then sent to the applications manager server. The server will analyze this data and provide insights into the performance and the behavior of your monitor application. This is an overview of the data flow through the data exporter using the data exporter. So the data exporter supports agents written in Python and PHP. So these agents are responsible for monitoring the applications to capture their metrics and traces. So developers or the IT team integrate the supported agents into their Python or PHP applications. So now these agents will collect the performance metrics, the traces, and other relevant data from application. A single data exporter instance is set up, which will handle data processing for multiple applications. As I mentioned, it acts as an middle layer between the application and the application manager server. So the application will continuously generate the data related to its performance, like traces and other metrics. And this data is collected by the respective agent, that is a Python and a PHP. So which are running within these applications, and the data exporter will process the collected data to aggregate, filter, and format it properly for transmission purpose. So this step will involve organizing the data in a way that is compatible with applications managers requirements, server requirement. So once the data is processed, the data exporter will establish the communication with the applications manager server. So we will then send the aggregated and formatted data to the server for further analysis and storage. The applications manager server on the end will receive the transmitted data from the data exporter. stores the data in a centralized repository and will provide the user interface for monitoring and analyzing the application performance, like the traces and the other metrics as well. So the system administrators and the developers or the IT team can make use of this data to monitor the health, performance and the traces of the application, so which will help in identifying the bottlenecks or the performance issues to optimize the application behavior. So unfolding the advantages of data exporter, the first one is the APDEX score will be more helpful in improving the customer satisfaction. The second and the third one is using the enterprise tool, and using this enterprise tool, you can pre-analyze the data and enhance the security to reduce the network load from the application. So you can alert your development team in prior and make your decision wisely before the application goes down, so which can improve your application in efficiently communicating and providing the customized data transmission. And along with that, as we discussed on the APM inside the agent, the data exporter, so we have something called the key performance indicators. So as displayed in this slide, these are some of the key performance indicators in APM Insight. The first one is the APDEX score. So APDEX score is a numerical measure of user satisfaction with the performance of the application's response time. So based on the response time, this APDEX score is calculated and provided. And the second one is the response time. So it measures the average time that takes for the applications to respond to the end user's request for that specific transaction. So across the complete application, so which can be lowering, and also lowering the response time in generally is more desirable to have better user experience. The third one is a request, so which is the total number of requests made to the application within a specific time frame and helps to decide the overload, overall load and the usage of the application. So it helps to identify them. So the fourth one is the data throughput. It indicates the amount of data in bytes transferred or processed in and out of the network request by the application during the monitoring period, so which will help in understanding the application's handling capability. The fifth one is the exceptions. So it will track the number of exception errors or the failures that occurs during the cycle of transactions in a chosen duration processing of the specific request. So these exceptions could be various types, such as errors such as the server errors, timeouts, or other issues that affects the application's normal operation. So let's understand the application performance with the help of AppDex scores. The AppDex score is categorized based on the application's responsiveness. The first one is the satisfaction. So this category represents the highest level of user experience, where the application's response time is between the satisfied threshold and the excellent threshold. The users in this category are generally satisfied with the application's performance. The second one is tolerance. The tolerance category indicates that the application's responsive time is between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance but may not be entirely satisfied as it comes under the satisfied category. So the last one is the frustration. So this category represents the lowest level of user experience, so where the application's response time is below the tolerating threshold. So users in this category are more likely to be frustrated with the application's performance as it does not meet their expectations. Now checking the application performance with the AppDex score. So this application performance index or the AppDex score mentioned is a standardized metric that used to measure the user satisfaction and the application response time. So the AppDex scale ranges from 0 to 1, where 1 being the best and representing the excellent user satisfaction. So based on the total samples that are collected, the AppDex score is calculated as a sum of satisfied plus half of the tolerating count over the total samples that are collected during the transaction period. Some of the advantages of monitoring application performance with the help of AppDex score. So let us see one by one. The first one is a user-centric performance measurement to understand the application behavior. So which will help you to understand how each application's performance directly impacts the user experience and enable you to prioritize the improvements. The second one is easy understanding of complex performance data with a common performance metric. So which will help you to simplify the complexity of the data into a single thing and easily help you to easily and understandable metric by providing a clear and standardized way to assess the application performance. The third one is you can benchmark and compare the performance level of different applications, allowing you to identify the high performance applications leading to a consistent improvement across your environment. The fourth one is proactive issues proactive the fourth one is the proactive issue identification and prioritizing of code optimization. So when the performance falls below the acceptable level, the APDEX code will help you to identify the critical transaction with low scores. So it will highlight the areas for code optimization. Alerts are triggered by enabling quick issue identification and improving the key transactions that impact user satisfaction as well. So at last, the historical APDEX trend data will allow you to analyze the performance pattern over time, so helping in understanding the performance trends and identifying improvements for ensuring a consistent positive user experience. So by now, you would be more interested in configuring the key business transactions to monitor the entire performance of the application effectively. So in this slide, we shall see on the configuring key transaction of your business operations. So which could be a high volume of activities made in this application. So all the transaction would be captured, among which you can select the key transactions that you would like to monitor, and you can try to set a threshold based on the response time of the specific transactions. So the application might have hundreds of thousands of transactions, but we can monitor the specific transaction, make it as a key transaction for monitoring. And now let's see how to monitor the code flows across the across applications via distributed tracing. So in the microservices architecture, it is necessary to monitor the transactions made between two or more applications or services. So with the distributed tracing feature, you can track the transactions made between two or more applications. So here, with the help of the tracking, how let's see how we can track the distributed tracing. So just understand and how the tracking is done in the distributed tracing level. In order to understand this, so an API request is made by a application to another application. The app manager, which is the APM inside, will add a HTTP header containing the metadata that is required to track the request. So if the APM inside is enabled in other application, it will process the HTTP header and return the tracking information to its caller via the response headers. So if the other application is in turns calls another service, so the other propagation will continue and trace all the paths that are taken by the original application across the distributed system. So using this data, we can monitor the start time, that is when the transaction was initiated, and the response time taken for the transaction to respond within the application, and the name of the transaction and the application. So by clicking on the expand view as seen in the screenshot mentioned on this slide, so you can view the method calls and the code blocks as well. So that take a significant amount of time to complete the request, and this will enable you to monitor calls made between applications and narrow down the problem effectively. So here we are adding to those features. Here we have something called the auto scaling in APM Insight. So auto scaling is an automated way of managing the resources of your application. So just imagine you have a website or application running on the cloud environment. So whenever the application automatically scales up due to high user interaction on the site, and to handle the extra traffic, a new instance will be added. Further, if you would like to have a personalized a demo in the it is a APM insight feature to see how it works on an environment. So kindly hit the poll displayed on the screen. So our team will reach you out. and we can using the personalized demo we can have the complete features covering this APM inside, and to see how it exactly works in your environment. And adding to the auto scaling feature, so however when these applications are scaled right, so due to the fewer user interactions or the newly added instance will become unused, it become unused, right? So it will be retained, so which will also use the license that been consumed in the instance level, not being considered or added for monitoring as well. So hence with the help of this auto scale mode in the APM inside, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. And the poll is still active, so if you would like to have a personalized demo for the feature, you can hit the poll. Our team will reach you out soon. Pinpoint to the problematic elements in your application code. So let's see the need to eliminate the issues in problematic code. So as you may aware, state trace represent the movement of an application during the execution of a program. When a Java application throws an exception, the stack traces get locked within it. So by enabling the stack trace providing by APM Insights, the developers can pinpoint the exact line of code and the sequence of the function calls that's leading to the issue. So this information will help them to understand the root cause of the problem and can make the code optimization or bug fixes to eliminate the issue and improve the application performance. So with that stack trace, the developers can efficiently troubleshoot and also resolve problems within the application's code, ensuring a smoother and more reliable user experience. So now by gaining deeper visibility into your Java-based application performance using the context-based monitoring, so you can enable context-based monitoring for your Java application. So this will allow the tool to track and trace individual user transactions, capturing data on how each registration transaction flows through your application. So let's say your application server has 3 Java applications running on it. By default, transactions of all the applications coming from the same application server are shown collectively under the Web Transaction tab in the APM inside. So in this image, you can see the Tomcat application in the application monitor name and the JPEG store sample and the sample web page are the 3 contexts running on the same application server. So these transactions of these applications for Java apps are listed in the Web Transaction tab. Now, with the context-based monitoring, you can monitor the performance of all the individual applications running in the same application server separately, which will help you to analyze your application performance. And this means that by enabling context-based monitoring, the transactions of the JPEG store, the sample web page, and the store sample can be viewed separately as well. We have introduced the RUM analytics feature in APM Insight, so which will provide real insights into your user interactions, allowing businesses to monitor and optimize application performance effectively. So by tracking these key metrics such as the response time, page view, JavaScript errors, and geographic performance trends, it helps to identify slow transactions, errors, and performance bottlenecks across different devices and locations. So this data enables organizations to proactively optimize their application behavior, ensuring a seamless user experience and improved the overall performance from the front end to the back end of your complete application. And adding to that, we have the application dashboard in Applications Manager, so which will provide a comprehensive view of an application performance and user experience. So by combining the data from the APM Insight and real user monitoring, so this integration allows from a unified summary of both backend and the user level performance. So which will help the IT teams to monitor the key metrics such as the APDEX score, user sessions, failed request, slow transaction, and error reports in a single dashboard. So additionally, the dashboard provides geographical insight to help analyze performance trends across different regions. By using this dashboard, organizations can quickly diagnose issues and optimize their applications to ensure a seamless user experience. And adding to that, in the recent times, we have revamped the Ad Monitor page for APM Insight to simplify the onboarding process, so making it more flexible and user friendly. So now, with this structured step-by-step flow, you can effortlessly configure the APM Insight monitoring setup. So later we have introduced the instance level monitoring alarm feature, which will allows you to configure alarms using a more granular set of performance indicators at the instance level. So this enhancement provides you a precise monitoring by enabling users to select the specific monitor and associate thresholds with key attributes. So by setting alarms for these instance level metrics, businesses can proactively track performance deviations, identify potential issues, and optimize application behavior more effectively. And going to the last slide, which is going to be visualize the dependencies in your application architecture with the help of automated service map. So what is a service map? Uh, Here. So the help of the service map, it will provide you with a complete overview of your application infrastructure along with the connection to the other dependent resources. So the main purpose of the service map is to identify the status of the application and its related instances. So in order to monitor the key metrics like response time, throughput, and the status of the connection, and to detect the troubleshoot with the help of to troubleshoot any application problems, so before the customers are get affected, and also to identify the number of failed requests as well. So these are three types of service map. One is the map view, the other one is a table view, and other one is the graph view. Here is the service map view. So it will provide a way of analyzing the topological view of the application along with its instances represented in the central node. So now, as we discuss all about the complete features and the technical details of the APM Insight feature, now let me take you to the Applications Manager user interface and showcase how all this can be achieved with the help of the APM Insight Monitor. So I hope the screen is visible. The API App Manager screen is visible now. And this is how the applications manager user interface look like. So in order to onboard a APM Insight, so I'm just getting into the monitor, add new monitor. So on the left side, we have categorized all the supported technologies, and we are going to onboard a APM Insight. So let's say we are going to onboard a Java application. And as I mentioned, it is a agent-based monitoring, and this APM Insight comes as an add-on feature. So there is a separate add-on licensing required for this. So I'm just getting into the Java application. So let's say I'm going to onboard a Java. So this is the the revamped ad monitor page that I mentioned in the slide. So if you still want to switch to manual steps, you can switch to the manual steps. And using this revamped page, we can choose the host. So after choosing the host, whether it is a Windows or Linux, I'm just choosing Windows. So let me choose the a framework of the application. So here I'm going to choose a Tomcat framework. So I'm just giving the next. There we need to mention the application name. It can be e-commerce application, whatever the application that you would like to name it. You can mention the application name and the port in which the application is running. And for mentioning the Java version, we can go to the next. So we need to make sure applications manager has the administrator privilege to your application hosted machine. So we need to copy this command and open this command need to be executed on your PowerShell. So once this command has been executed, the agent deployment will be directly completed with the help of applications manager. After configuring the argument, so the monitor will be added successfully. So once the monitor has been added, it will be available under the APM tab. So you can get into the APM tab to see the onboarded APM Insight monitors. I'm just clicking on the Java application. Let's assume this is the monitor that we onboarded. And I just want to see the data for the last 30 minutes. As it is a real-time performance monitoring, so we can see the complete performance for the last 30 minutes. So these are all the key performance metrics that we discussed. The first one is that the APDEX score. So which means here we can see 75% of the users are satisfied, 24% are tolerating, and 3% are frustrated. So this APDEX score, as I mentioned, is calculated based on the total response time. Response time, as you know, based on the user experience, this response time is calculated. How response time is works, so based on the transaction, what are the transactions that the users are made, so how many time that is taking for to complete a specific transaction, and that is the time we call as response time. And in the last 30 minutes we can see around 1488 requests were sent, and per minute 50 requests are getting in. So in this count, we can find 24 percentage of the requests are having errors, and the data throughput. This is a data throughput, and in the last 30 minutes, these are all the fatal and warning exceptions attempted on your application. So if you scroll down even more, instead of so your application might have millions of hundreds of transactions. So, but we in order but by monitoring a complete transaction, so we need to monitor the specific transactions that is causing difficulties for the end users. So in order to do that, I'm just trying to figure out the top 5 transactions. So under the APM tab, so we can see the top 5 transactions that is taking more time. So compared to the other transaction, we can see this other top 5 transactions that is taking high response time. Now I want to identify the root cause. So 20 milliseconds is something very low, but in the production applications, there are transactions that may cause the high response times. Okay, then why it is causing high response time? I just want to drill down. So I'm just clicking on the specific transaction. So if I click on the specific transaction, it will take me to the transaction tab. We can able to see the APDEX score, average response time, and the request that has been taken for the specific transaction to be executed. If I scroll down even more, I can see this graph. By hovering to this graph, I can see the contribution of the code. So whether the application code is taken around 17 milliseconds, and the JDBC is taking around 3 seconds, and the overall response time is 20 milliseconds. And if I scroll even more, I can see the complete request throughput details and the split by exceptions as well. So apart from that, if there are any traces available in the transaction, so in this transaction tab, from the overview, we found the top transaction. So with that transaction, we can able to find the traces that is taking more time. So these are all the top 5 traces that is having the high response time. In order to drill down into the code level stack, I'm just clicking on the specific traces. So this is one of the trace that thrown at 502 error, and in order to complete this trace, there is a response time, 15 seconds of response time taken. 78 around 87 milliseconds of CPU time has been used along with this memory on the method calls. If I scroll down, I can able to see the complete trace details. So we need to share this detail with our application team in order to optimize the performance. So totally for this specific transaction to be completed, it requires 3 method calls and 1 SQL calls. So under the SQL statement, we can find out what is the SQL call that is executed for this transaction to be completed. If there are any external calls like the JDBC call, or if there any PG call that is available, we can see that specific call that was communicated. And if there are any other transactions that has been identified, we can see that as well. So from the transactions to the traces, we can identify the code level stack and the method calls taken for the transaction to be executed. So by sharing those method call details with our application team, they can optimize the application to optimize the specific transaction. So under the database tab, we can have the complete visibility over the database and what are all the queries that has been getting executed on the back end of your application. It might be a select query, update query, insert query, or delete query. So by clicking on the all and clicking and averaging using the average response time, we can find which specific query that is taking more response time, and what are all the transaction, and for which transaction that query has been executed. So these details can be identified under the database tab. And as this is a Java based application, so we have this JVM tab. So you can monitor the complete JVM usage and the performance of it. So under the summary, so we can identify what is the CPU usage of the Java that is taking, what is the JIT time, what is the run memory, how many classes are getting loaded and unloaded in the last 6 hours, and what is a heap memory, non-heap memory. So by having this comprehensive view of your complete application performance, if there are any deviations from the normal behavior, we can able to optimize with help of our application team. And we have the garbage collector. So under the garbage collector, we can able to see the time spent for the last 6 hours, and what is the collection count, and how much time that was spent, and what is the collection count since the JVM was started. So these are all some JVM details so we can able to identify. And under the thread details, we can have the complete thread performance. And along with that, we have the exceptions tab. So in the exceptions tab, we can able to identify the exceptions over here. So what are all the top exceptions, and in which transaction those exceptions was captured, and how many error codes were occupied. So likewise, we can check those details. So in this Java application, there are in the last 6 hours, so totally 500 code has been identified as 3000 times. The 404 error code has been identified 324 times. So if I scroll down even more, I can able to see in which transaction that error code has been attempted. So I can make this transaction with the help of application team. I can optimize this transaction in order to prevent that 404 code to be attempted again. And this is something called the service map that we discussed. So this service map is nothing but, so what are all the components that are associated within your application will be displayed in the service map view. So in order to checking with separate team, maybe a database team, maybe a separate application server team, or the application where the server is hosted. So in order to checking the each other servers team separately, you can directly, by hovering to the specific instance, you can check the health availability of the specific instance. Let's say this is a Java application and it has HTTP calls and accumulated and associated with these instances. By hovering to a specific instance, I can able to identify the health and availability of the instance. For example, let's say this is a database that is associated and it is showing as down. So in order to checking the issue, we can directly connect with our database team to identify the issue directly. And this service map is also available under the graph view and the table view as well. So app parameters. So app parameters can be created under demand. By default, we can JMX parameters will be available. If you have any custom requirements, you can directly generate the app parameters from your side. And we have the thread profile, and this thread profile also can be created in demand. So based on the threads that is available, so we can on demand we can create a thread dump, and at the time we can see what are the threads that is taking more time, and what is the stack trace of that specific thread. So we can share this complete information with our internal team to optimize the performance. And along with the thread profile, this is the rum analytics that I mentioned. So using this rum analytics, so you will be seeing this complete detail of the real user monitoring in the upcoming digital experience monitoring webinar. So rum analytics is, in order to give a overview, rum analytics is going to be the front end performance of your application, real time user experience of your application. So under this rum analytics, we have the APDEX score response time, how many pages, and the JavaScript errors. So along with that, we can see the geographical view from what are the geographies where your application has been viewed, and the complete performance metrics over here. So this is a complete front end details of your application. So along with this complete APM Insight feature, so we have that application dashboard. So this is application dashboard we discussed. So using this application dashboard, we can have the comprehensive view within your application front end monitoring and the APM insight monitoring. So we can get the top running queries, top errors, and how many requests are getting in and out, and the geographic map view as well. So by having this application dashboard view, your application team can directly check the status of your application for the request and the crucial metrics. So along with this, if we get into the configure alarm section, as I mentioned about the instance alarms. So previously we have the feature to configure alarms in globally. So in the instance level, you can choose the instance and configure alarms for this crucial metrics. It can be availability, health, availability, AppDex score, frustrated percentage, satisfied percentage. As this is going to be a Java application, you can configure alarms for the JVM CPU usage, JVM CPU usage as well. And you can configure this alarm and get notified in any of those actions. So it can be, you can get notified with help of email, you can execute a program. If you are using a cloud based thing, so you can you know create or restart a specific VM, or any of these actions mentioned over here can be utilized. And apart from this APM Insight, we have the reporting feature as well. So in this reporting feature, so you can directly fetch the reports of your application thing. And this is how the application inside APM Insight works. So in order to show you a more interactive way, just showing you, this is a Java pet store application that I hosted on my own. So I'm just making a transaction over here. So suddenly I'm getting into a 4.0 error. So this 4.0 error has been identified for this application. If I get into this app parameters, I mean exceptions, so after some time, so I can identify the 4.0 error over here. The 4.0 error can be captured over here. So this is how the application performance monitoring works in App Manager. So after discussion within the slides and the user interface demo, so let's have a quick recap of today's session. So in the first part, we discussed how to track application performance using the APDEX score. Next, we explored how to identify the problems in the application code. In the third segment, we saw how to track transactions from one application to another and debug the issues proactively. In the last part, we encircled identifying problems in the code stack and concluded by discussing on how the service map makes it easier to identify the problems. Okay, everyone, I appreciate your time and participation. Have a great day.